Hi everybody. So as you guys know, I'm not going to be here today, and as I told you guys last week, I was going to be recording a lecture for us so we can still accomplish our goals for today, even though I'm not here. So that's what we're going to be doing. You guys all should have received a packet that looks like this, not in color, but it looks the same. Factors that affect climate. That's what we're going to be talking about today. There's 3 pages for you guys to take notes on. All right. I will be looking at this when I get back tomorrow. All right, and you will be getting a classwork grade for it. I'm going to be moving fairly quickly through these slides, but feel free to pause it, to slow it down. If you need to, rewind it, to make sure you get all the notes so you can move at your own pace, but I'm just going to keep going through it. Also, expect your homework for this week, which you should have already, is going to have questions based upon this stuff too, so, it's very important that you guys do this and pay attention to this. All right, so let us begin. All right, so today's objective, we are looking at factors that affect climate. So at the top of the first page in your notes, there's a little box for the do now question, and I want you guys to answer this. Why is the climate in these places different? List as many factors as you can. The picture on the left is just a beach in the DR, and picture on the right is a house in Colorado. All right, so take a moment, pause this video if you need to, and think about what are some of the factors that will cause it to be nice and warm and sunny in one place, but cold in another place. All right, so that's what we're going to go through today. So let's do that. So hopefully you wrote something down similar to this. The beach in DR is in the south. It's close to the equator. Colorado's in the north. So it's going to be a temperature difference. One is near the ocean, one is inside of the land. Mountains versus sea level, elevation changes. Those are all correct answers, and there's many more as well. So we're going to talk about all of the factors that you see here, and that's everything that's covered in your notes. So latitude all the way down to clouds, because all of these things here will affect the climate of an area. So let's start with latitude. This, I would say, is probably the most complicated of them. So we'll get that out of the way first. So as you increase your latitude, meaning going from the equator up towards the North Pole or from the equator down towards the South Pole, the intensity of the solar energy decreases. And we see this word here that we've used before called insolation, right? Insolation is incoming solar radiation. We talked about this when we were talking about specific heat and heat transfer, phase changes, that kind of thing. So when you are on the equator, you get direct sunlight, which is why it causes temperatures to be warmer. As you can see here, the sun is going straight at a nice perfect angle down towards the equator, and that's going to cause it to be warmer. But as we get towards the poles, the sunlight is less direct. Therefore, it makes it colder. All right? So that's why the North Pole and the South Pole are colder than the equator, is really because they just get a more shallow angle of sunlight every day. They realistically get less energy from the sun than we do at the lower latitudes, like where we are, and down towards the equator. All right? So make sure you wrote all of that down in your notes. The second factor is going to be altitude. Altitude we've talked about before. It's your height above sea level, right? Your elevation. We talked about that at the beginning of the year. We talked about that a few weeks ago when we were looking at how weather changes in the atmosphere. So looking at this picture here, you see one person standing on the rocks of the beach and the other person all the way up in the mountains. Which person do you guys think is going to be colder? Well, hopefully you said this guy up here. And that would be correct, because he's up in the mountains. That's at a higher elevation. So write this down in your notes. The higher the elevation, the colder the climate. All right, the higher the elevation, the colder the climate will be. It's pretty straightforward. We could see this on our reference table as well, page 14, with the little graph showing how temperature changes as we go up deeper into the atmosphere. Okay, our third factor is topography. So remember topography again from the beginning of the year. The change in elevation, mountains, valleys, plateaus, the different landscapes. Okay? So mountains cause moist air to rise, then cool, and then cause precipitation. So it'll rain or snow. Right? And what we see as an example of that is a mountain with a leeward side and a windward side. Now, this is not the first time we've heard these terms. We talked about this a little bit last unit with weather, and we talked about it when we were talking about sand dunes earlier in the year, and we were doing weathering and erosion. But the mountain has two sides. So let's take a look. I have this animated here on how the air is going to travel. Okay, so we have a hot air mass, as we can see in this picture down here, and it will be full of water vapor. There'll be some water vapor in it, and it's going to move up the side of the mountain. But notice the color change. It's getting cooler as it's going up the mountain. Okay, and it's reaching the dew point. Remember, because as the air cools, it shrinks, and it will reach the dew point, which means it'll have 100% humidity, and clouds will start to form. Once we get the clouds, it's going to precipitate. Right? It's going to rain or snow, sleet, hail, whatever it is. Okay, so as that air mass continues to move over, it's going to get drier and warmer. As we can see here, warm air is expanding, and it's dry. All right, so this is the path that the pocket of air takes. And we can see that the side where it is wet and cool is the windward side, and the side where it's dry and warm is the leeward side. Okay, so cool and wet, warm and dry. Make sure you understand this. This is a important concept. Okay, there's usually a question or two on the regions about windward versus leeward. All right. And then this is the picture that's in your notes. So you can see here as it's pointing to the moist, wet side versus the arid, dry side. Windward versus leeward. Okay, so here's an example of this. This is a satellite picture of Hawaii, and it's saying draw an arrow to indicate the direction of the wind. Okay, we can look at this picture and say, oh, wow, look, there's a lot of vegetation. It's green over here, but it's brown over here. You know, this is probably more desert-like. And we can see that the wind is moving in this direction. Okay, because on this side where we see the vegetation, that's where we're going to have the cooler, wetter air cause precipitation, that'll allow things to grow. But by the time the wind gets to this side of the mountain, it's dry and it's warm. And that's just how it stays. All right, so nothing grows over there. Okay, our third, or our next factor, is land versus water. So, where you are located in terms of on the continent, even just here in the United States, is going to also affect your climate. If you're closer to the water, you're going to have a different climate than if you're in the middle of the land. So let's look at some examples. Here's a house on the beach versus, a house on a prairie of Kansas. They're going to have two very different climates throughout the year. So the areas that are by the ocean, by the water, are going to have cooler summers and warmer winters. Okay, so write that down in your notes. Areas near a large body of water have cooler summers and warmer winters, whereas areas that are more inland, areas surrounded by land, are going to have very hot summers and really cold winters. All right, that's a big difference there. If you want more temperate environment, temperate meaning not as much of a change throughout the year, it's more mild, you'd want to live somewhere by the water. Okay, the summers are not super hot, the winters are not super cold, but as you get farther inland away from the water, it's going to be extreme. Very hot summer, very cold winter. Okay, and this is due to the specific heat of the water and the rocks. Okay, as we know, water has a very high specific heat, so it holds on to that energy, that heat, and it doesn't allow the temperature to change as quickly. So it will stay more level, whereas the rock does not have a high specific heat, so the temperature changes much faster. All right, so let's look at an example of this using two areas here. Here's San Diego, California, and a town called Brownwood, Texas. So this is actual atmospheric data. or temperature data from over 10 years ago. It's an old data, but it gets the point across. This is from 2011, 2012. So the red is Brownwood, Texas, and the blue is San Diego, and this is showing over the course of a year the temperature fluctuations in Celsius. Right? Now they may look a little similar, but here's a line going across for San Diego, and here's one going for Brownwood, and we can see that they are actually have a much different temperature change throughout the year. Notice, as we said, the area by water, San Diego, is going to only fluctuate a little bit. All right, the temperature gets a little higher, a little lower, but it stays relatively straight, whereas the red line for the place that's very far inland, in the winter it's very cold, in the summer it's very hot. All right, so if you didn't already write in your notes, here's this written out for you. So areas near a large body of water have cooler summers and milder winters. Areas surrounded by land have hotter summers and colder winters, an extreme temperature difference. All right, so make sure you have all that written down. All right, our next factor is geographic position. So where on Earth we're located, not just in terms of are we close to the water or are we close to or are we inland, okay? But think back to our air masses. Where does the wind come from? All right, so you should be writing this down in your notes. Prevailing winds bring distinctive air masses with characteristics of where it comes from. What that means is if we have a CP here, which is continental polar air mass, okay, that's going to be cold, that's the P for polar, and it's going to be dry for the C for continent. Versus something like MT, marine tropical down here, is going to be wet because it's from a marine environment and warm because it's from a tropical environment. And we also have MP and we also have CT. So there's every variation of it, but that's also going to affect the climate of the area based upon the air masses that is coming from. All right. Next factor, we have the type of surface, the color and the roughness. This also goes back to what we talked about when we were talking about heat transfer and energy. We talked about how a more smooth surface will reflect light, right? It won't absorb heat, but a rough surface will absorb the energy in, and how a darker surface will also absorb more energy, whereas a lighter surface will reflect it. Right? So as we see here, this is showing these are percentages of the light from the sun, the radiation from the sun, that's being reflected off. So on a fresh snow, very light, very smooth, it's going to reflect almost all of the light that hits it. Versus something that's rough and dark, like a forest, it's going to reflect barely any of the light. All right, that should just be a review. We covered this topic already, but that is going to affect the climate of the area. So, write this down. Different surfaces absorb and reflect different amounts of insolation, which once again, remember, insolation is the energy from the sun, the incoming solar radiation. All right, we are almost done. Write down the last one. The last factor that's going to affect the climate. Oh, actually, we have an example first. Sorry. So here's an example for this that I made for you guys, giving the the current controversy with Drake and Kendrick. So if both of them are going out on a hot summer day, but they don't want to sweat, they want to stay cool. Here's Drake. He's wearing a black sweats and a sweatshirt. Kendrick's got this whole white outfit here. Which one made the better outfit choice for a hot summer day? Well, that would of course be Kendrick, because as we know, the white clothing is going to reflect the sunlight, which will help him to stay cool, versus Drake, the black clothing is going to absorb the sunlight, heating up and then heating him up as well. So then he'll start to sweat. All right, so better outfit choice is Kendrick here. And then as another example, here is two surfaces, okay, one dark, one light. And this is a thermometer. So they're right next to each other. This is the same day, all right? But we just took like a black slab of concrete or a marble slab and put them out there, and notice that while still hot, the white slab is much cooler, 90 degrees versus 150 degrees, roughly, that the temperature difference is. All right, so the white slab is going to absorb a lot less of that radiation than the dark slab. It's not saying one is better than the other. It's just going to change the climate of the area. All right, so the climate will just be different based upon those two factors. Okay. And for that reason, we sometimes, depending on the environment, will paint roofs certain colors as well, if we want them to not heat up, right? If we want them to reflect the sunlight, or if we want them to absorb it. Okay, so this comes into effect in, city planning, engineering as well. Okay. As you can see, here's an aerial view showing, a lot of the roofs of buildings are painted white, so they reflect that light, so they don't, heat up, especially in the summer times, and cause have to use a lot more energy and more money to cool down the buildings. All right. So finally, our final factor here is clouds. So write this down. Clouds make it cooler in the summer. They block the sunlight. We've also talked about this a little bit as well during heat transfer. So this should all be relatively familiar to you all. But as we can see, the energy from the sun is coming down, and it's blocking. The clouds are blocking it from reaching the surface, which is why we've talked about how on a cloudy day, the temperature doesn't change that much. It stays similar. It's going to be cooler, right? Because the sun's energy is not able to come down to heat up the land and make it hotter during the daytime. Okay? So clouds make it warmer at night. They keep the heat from escaping back into space. All right? So cooler during the daytime, warmer at night. Okay, because at night, if the clouds were not there, all the energy would just leave, right? And it would get very cold. And we've talked about this in class on how on a nice clear day, we'll have a very large range in temperatures. When you wake up in the morning, it might be 45 degrees, and then it gets to 75 degrees in the afternoon, and then back down to 45 degrees at night. But whereas when it's cloudy, right, it stays at that relatively cool temperature in the summer, or cool temperature in the summer, so it might get to 50 degrees, 55 degrees, but we're not going to see that huge variation again, right? And the energy that is able to come to the surface then can get trapped there because of the clouds as well. So at night we'll have more moderate temperatures, won't get as cold. Okay, so once again, not a good or a bad thing. There's benefits, there's negatives to each, but these are just things that are going to affect the climate of the area. All right, so that was everything. The last thing I want you guys to do is complete this exit ticket on the bottom of page 3. So now, and you'll notice this is very similar, it's the same as the do now. Now that we have this information, name and explain 2 factors that cause these locations to have different climates. All right, take as much time as you need. I'll leave you guys there. Once again, remember, I am going to be checking this tomorrow when I get back. Your homework this week is going to be related to this, so please make sure you fill out your notes and have thoroughly watched this video. I know I moved fairly quickly through things, so once again, feel free to pause, rewind, rewatch the video if you missed any of the notes. All right, I'll see you guys tomorrow.